All right, starting lesson 4.7, inverse trigonometric functions. All right, here's just a little recap to refresh your memory. Sine of 30 degrees. How do you figure that out by hand? Well, we rotate 30 degrees. There's our terminal side. We construct a triangle. That's 30 degrees. So if that's 30, that's 90, that's 60. All right, and we start off with the short leg across from the 30-degree angle. We'll call that 1. What do you do the short leg to get the long leg? Multiply by square root of 3. What do you do the short leg to get the hypotenuse? Multiply by 2. All right, so this is your hypotenuse. The side along the x-axis is your adjacent side, and the short leg that runs parallel to the y-axis, that's your opposite. All right, so here I have sine of 30 degrees. Sine is opposite over hypotenuse, which is simply 1 over 2. Done with that. Here we have sine of pi over 3. Well, pi over 3 is the same thing as what in degrees? Refreshing your memory, pi over 3 times 180 over pi. This is your converting fraction. You get 60. All right, so this is the same thing as sine of 60 degrees. All right, so we rotate 60 degrees. There's my triangle. 60 degrees, that's 30. All right, so across from the 30-degree angle is my short leg, that's 1. Then I have my long leg across from the 60-degree angle, multiplied by square root of 3. Then I multiply my short leg by 2 to get the hypotenuse. So that's adjacent, that is opposite, that's hypotenuse. And sine is opposite over hypotenuse, so it's going to be square root of 3 over 2. All right, there we go. Done with that. All right, the trig function of an angle measurement yields a ratio. That's what we worked with in the past, and that's what we just obtained for our answers, right? Now, today we're working with the inverse. All right, and the inverse is a very useful tool. The inverse trig function of a ratio yields n. So here we went from an angle to a ratio. Inverse allows you to go from a ratio to an angle. Alrighty. All right, now here we have the three inverse functions: sine, cosine, and tangent. All right, now a couple things to take note of. The notation that's being used. Here we have arc sine. Here we have sine with like an exponent, although it's not really an exponent, it's just the notation with a -1 there. If you see either of these, that means you're working with the inverse of the function. Okay? So arc cosine, sine with, and then you have cosine with -1, arc tangent, then you have tangent with the -1. A couple other things to be aware of: there are angle limits, and there's a whole explanation around why there are angle limits, but you could go by your yellow sheet for these. For sine and tangent, the limits are the same. It goes from -90 degrees to 90 degrees, or in radians, -pi over 2 to pi over 2. All right, same thing. All right, in other words, you're limited to quadrants 1 and 4. For cosine, it's a little different. All right, your angle limits is from 0 to 180, or 0 to pi. So that leaves you in quadrants 1 and 2, or restricts you just to those quadrants alone. All right, one important thing to take note of is that the -1 that we have for the inverse of sine is not a power. All right, it represents inverse notation. So please don't take this and convert it into this. That is not true. All right, be careful. All right, let's do a couple examples now. You're going to use your yellow sheet to apply this knowledge here. All right, example 1. Here we have the inverse of sine of -1 over 2. Okay, so in this case, we have sine, which is opposite of our hypotenuse, and hypotenuse is always positive, so opposite must be negative. Alrighty, and for sine, we're always working in quadrants 1 and 4. All right, now let's see. Where would the opposite be negative and hypotenuse be positive? So if opposite's negative, that's your y value. All right, that means we're down in quadrant 4 then, because we're restricted to quadrants 1 and 4. All right, and then so this is your -1, that's 2, and I know that since I have these lengths here, -1 and 2, the properties of a 30, 60, 90 should stand out, so this is 30 degrees here. Okay, and I know this is the short leg. And that's all you really need to figure out. Okay, once you set up the triangle correctly, all right, you're just identifying this angle here, right, your reference angle. So in this case, it's -30 degrees, or in radians, it's going to be -π/6. Okay, that's all there is to it. So we went from a ratio now to an angle measurement. That's what inverse trig functions are for. All right, let's do another example. Now we have sine. Here I have opposite over hypotenuse. That's positive, so opposite's positive. Okay, let's see. I'm only working in quadrants 1 and 4 for sine. So constructing a triangle, let's see. I have positive square root of 3, so it must be like this. That's square root of 3. All right, and that's 2. Okay, and you should recognize then that the properties of a 30, 60, 90 stand out in this triangle. So this is going to be 1 here, which makes this the long leg, which makes that 60 degrees. So this is 60 degrees, or π/3. Radians. All right, it's simple as that. All right, here I have 2 over 1. I have opposite over hypotenuse. Hypotenuse is positive. Opposite is positive. All right, I'm only working in quadrants 1 and 4. So I'm constructing a triangle. My opposite is positive. That means I'm in quadrant 1. Okay, that's 2, and that's 1. Okay, now right away something should stand out. Can any of the legs ever have a length greater than that of the hypotenuse? No, that is not possible. All right, and if that's the case, then there's simply no solution to this problem. All right, let's do some more examples. All right, working with cosine. Cosine is adjacent over hypotenuse. Hypotenuse is always positive. Adjacent in this case must be positive. With cosine, we're working in quadrants 1 and 2. All right, so let's see. Adjacent's positive. That means I must be in quadrant 1. All righty. So that's square root of 2, and that's 2. All right, after you set up this triangle, you should recognize that if I multiply this leg by square root of 2, that gives me the hypotenuse. That's the property of a 45, 45, 90. All right, so there's my answer. 45 degrees, or π/4. All right, going on to inverse cosine of -1. Put that over 1. Adjacent over hypotenuse. Hypotenuse is always positive, so adjacent must be negative. Okay, I'm only working in quadrants 1 and 2. And let's see, this is the one that a lot of students have trouble with. Where is adjacent -1? So the x value has to be -1. That means it lies along the x-axis. All right, so that's -1. All right, if you can't see why that is, well, imagine this triangle is collapsing. What's happening to the x value? It's getting longer and longer, and the y value is becoming 0. All right, and then the adjacent side and hypotenuse become the same. All right, so what's the rotation here? That's 180 degrees, or pi radians. Done with that one. All right, next one is inverse tangent of 0. All right, so you have 0 over 1, and tangent is opposite over adjacent. And with tangent, we're only working in quadrants 1 and 4. All right, to end up with 0, your opposite must be 0. All right, now this is an O. This is just a 0, and it could be over any number, 1 or any number, it doesn't matter. So where would your opposite value be 0? That's your y value. All right, so pay attention to this here. If this triangle collapses, what's happening to the y value? It's getting smaller and smaller until it becomes 0. All right, so here's my opposite value, or my y value, that's 0. So that means you haven't rotated at all. It's 0 degrees or 0 radians. Let's do a couple more examples. Inverse tangent, -1 over 1. Here you have opposite over adjacent. And since you're only working in quadrants 1 and 4 with tangent, your adjacent has to be positive. All right, because this is your adjacent, right? It has to be positive when you're in quadrants 1 and 4. So your opposite must be negative. All right, if that's the case, then here's my triangle down here. And this is 1, this is -1. Now since the legs have the same length, this would be the property of a 45, 45, 90 triangle. So we're rotating -45 degrees or -π/4. For the next one, cosine. Cosine is adjacent over hypotenuse. Hypotenuse is positive, adjacent is negative. All right, for cosine, we're only working in quadrants 1 and 2. All right, now adjacent's negative, that means we're in quadrant 2. All right, let's make a triangle. And then I have -1, and the hypotenuse is 2. Okay, so that would make this square root of 3 over here. And that's the long leg, so that makes this 60 degrees. So then you have to ask yourself, what was the rotation that took place? Because the answer isn't 60 degrees. A lot of students put 60 degrees. You always ask yourself, what's the rotation? So in this case, it's 120, right? 180 minus 60. Now, 120 degrees is the same thing as 2π/3 radians. Done with that. All right. Last one of this type, tangent, inverse tangent. Here I have opposite over adjacent. And for tangent, I'm only working quadrants 1 and 4. So adjacent has to be positive. Opposite is negative. All right, so if opposite's negative, I'm in quadrant 4. All right, so that's a negative square root of 3. And adjacent is 3. Okay, you have to think a little bit about this one. If I take this leg and I multiply it by square root of 3, I get this leg. All right, that'll be the property of a 30, 60, and 90 triangle. So that's your short leg. That's 30 degrees there. All right, so you're looking for your rotation once again. So you rotate -30 degrees or -π/6 radians. All right, pretty simple stuff once you get the hang of it. All right, in the last example, you're just punching these values into your calculator. All right, using the TI, you hit second, and then you hit the trig function to get the inverse. So plug these in your calculator. And then depending on the mode that your calculator is in, you may get a different result than your neighbor. All right, so just hit the mode button. Make sure your calculator is first in degree mode, and you'll get 14.16 degrees. And then put it in radian mode, and you'll get 0.25 radians. All right, and same thing for the rest. Here you'll get -83.25 degrees or -1.45 radians. And the last one, you won't get a solution. You'll get an error, and when you get an error, that's an indication that there is no solution. You can't take the inverse cosine of 2. Okay, that's all there is to it. If you have any questions, if you need any clarification, please make sure to ask for help. All right, begin the assignment at the bottom of the web page.